time for me to discover this kind of meeting. So today we will have 3 presentations, and then we will have some discussion on the dynamic of structure and especially on the wind engineering. The first presenter will be Dr. Owen, who is Associate Professor in Faculty of Engineering, University of Nottingham in United Kingdom. Dr. Owen research interests are in the dynamic response of structure to wind excitation and the structural health monitoring of civil engineering infrastructure. He has led the monitoring program on the Quoc-Bao and Forth Road Bridge in Scotland, and is currently collaborating with colleagues in Ho Chi Minh City to monitor cable stay bridge in Vietnam. So maybe I will let Dr. Owen to begin his presentation and introduce some complementary points about his issues.
Thank you very much. Thank you very much, everybody. Good morning. And I'm going to share my screen now. So I hope you can see that.
Not yet.
Not yet. Ooh. There.
Now it's coming. Yeah.
Okay.
Perfect.
Excellent. Well, good morning, everybody. And as Bui says, my name is John Owen. I'm from the University of Nottingham in the UK. And I'm just going to introduce a little bit of what we're doing in wind engineering research, and also talk about or introduce the IRIS project that Cung and Jörg are going to say a little bit more about. Just to introduce myself, I'm, as Bui said, an associate professor at the University of Nottingham. I've been there since 1993 on the academic staff. I'm served 5 years as head of Department of Civil Engineering, and I'm now the faculty director of educational development in the Faculty of Engineering. So let me just tell you a little bit about the University of Nottingham, and in particular my research group, which is the Centre of Structural Engineering and Informatics. For those of you who don't know the United Kingdom very well, we're situated right at the heart of the United Kingdom. We're right in the middle, in the city of Nottingham, famous, I guess, for Robin Hood, but hopefully for much more. So this is our University Park campus, but we're not just a single campus university. We have 3 campuses in Nottingham, but we also have campuses around the world. We've got a campus in China at Ningbo and a campus in Malaysia at Seminyi. So we like to think of ourselves as a truly international university. We have we're members of the Russell Group in the UK, which is a group of the leading elite research intensive universities. So those are our campuses in Malaysia and our campus in China, where we've been since 2000 and 2006, respectively. Moving a little bit closer to home for me, for the Faculty of Engineering, we're currently ranked 3rd in the UK for research power in our research excellence framework, and we're very confident we're going to do even better in the upcoming research excellence framework exercise, which begins at the end of this year. This is a second of our campuses in Nottingham. It's our Jubilee campus, which is about a kilometre or so from the University Park that I showed you a moment ago. Within the Faculty of Engineering, we've got 6 teaching departments, but we're talking mainly about research today. We've got research priority areas that span everything from advanced manufacturing and aerospace through to transport technology, sustainable and resilient cities, and the water industry. We've got 4 major research institutes and 22 research groups in the faculty. And my research group is the Centre for Structural Engineering and Informatics, and our research areas cover structural and computational mechanics engineering, design, and construction informatics, which you see across the bottom of the screen there, moving from CAD models through BIM models to analysis models, and then combining the two together to give useful output for construction professionals. We've got work on construction material and structural strengthening, which we see in the top right, and also in wind engineering and structural dynamics, which is my area and my interest that we're talking about today. So to highlight what we do in terms of wind engineering, a lot of what we do is now computationally based. So we do computational wind engineering where we couple CFD models, as you can see in the top left. This is a mesh around a rectangular section that is a typical or generic bridge deck shape. We connect those to structural analysis models. So you see on the right-hand side, we've also got access to wind tunnels. So there's a section model of a bridge deck in the top and a model of part of our campus in our boundary layer wind tunnel in the lower image. And then on the bottom left, we're currently involved in monitoring the Forth Road Bridge, which is just north of Edinburgh in Scotland. So we look at full-scale wind engineering. In terms of dynamic responsive structures, we've done work on human structure interactions. This is a former PhD student of mine on a rig where we got him to walk on a treadmill on a moving base and monitored what happens to his gait pattern and the loads that's applied to the bridge. And then structural health monitoring, both wind response, as I've already mentioned, but also looking at damage detection, and can we use the vibration data to detect and simulate damage in structures. So that's an overview of the research that we're doing within the research group at Nottingham, and my particular interest in wind engineering and dynamic responsive structures. Now let's focus in on infrastructure resilience in storms, the project which we're working on, the three presenters today. This is a 3-year collaborative project between the University of Nottingham, the Vietnamese-German University, and the Industrial University of Ho Chi Minh City in Vietnam. I've listed the people, the main investigators. The funding came from the Royal Society through its International Collaboration Awards, with funding from the Global Challenges Research Fund, GCRF, which is a UK government scheme to use research fundings to help developing countries around the world. This is an early picture of the Royal Society, which is one of the oldest scientific institutions in the world. The context is, of course, storms in Vietnam, and Vietnam is vulnerable to extreme windstorms. Over half of the large tropical storms in the South China Sea strike Vietnam each year. They cause significant damage to slender, lightweight structures, as you'll see in the images on the right-hand side of the screen. There are telecoms tower and transmission poles that have been damaged in typhoons in 2012 and 2016. And they also lead to significant economic impact and also loss of life. So typhoons are a very major threat, major hazard, and we want to make infrastructure more resilient to them. So our research objectives include producing a new wind map for typhoon winds in Vietnam based on the simulation of typhoon tracks. We want to develop new models for particular types of responsive slender structures in strong winds, in particular galloping. And we're doing that through a combination of CFD simulations, theoretical modeling, and simplified analytical models that can be embedded within design codes. And then we want to develop a risk-based model or a risk-based network resilience model to enable us to essentially build back better. And to show you the basis of that risk-based resilience model that we're putting together, it starts off with a hazard model in which we're doing a Monte Carlo simulation of typhoon tracks to produce a probabilistic model of hazard in Vietnam, and from that, the wind map. That hazard model will feed into a vulnerability model, where we try to capture the structural response to the wind, and then use, as I said, a combination of CFD and also wind tunnel tests to assess the probability of failure of those structural elements. We need to bear in mind the consequence, so what is the result of a system failure? So what are the costs of failure? We can base that on typhoon field reports and also on simulations of network failure. And from that, we evaluate the risk, the estimate of the probable losses in a future typhoon. And that feeds into resilience in terms of planning interventions that allow us to build back better, so we can reduce the vulnerability, reduce the consequences, and hence reduce the risk of future events. So that, in a nutshell, is a very quick overview of the IRIS project, and I now want to hand over to Cung, who will tell us more of the details. Thank you very much.
Okay. Thank you very much, Dr. Owen. So we will follow the second presentation, and the discussion will be done at the end of this webinar. So the second presenter is Dr. Cung Nguyen, who is actually a research fellow at Faculty of Engineering, University of Nottingham, United Kingdom. So it's the same university as Dr. Owen. Dr. Cung Nguyen has received a PhD degree in wind engineering from University of Genoa in 2013, where he continued as a postdoctoral researcher. He won a grant from the Royal Academy of Engineering Newton Fund to spend a year working at the University of Bristol. Dr. Nguyen was also awarded various fellowships to work as a visiting researcher at the University of Leeds, UK, Tokyo Polytechnic University in Japan, and Thang University in Taiwan. His research has focused on modeling of wind loading, wind-induced structural vibration, and structural resilience to typhoon through the use of analytical, experimental, and computational approach. So please, Dr. Cung, you can start your presentation now.
Thank you, Dr. Boyd. My name is Cung. Hello, everyone. Hello, good afternoon from the UK. Good afternoon, good evening from everywhere in the world. So I'm going to share you my screen. Sorry, can you see that?
Not yet.
Try it again.
Now it's coming. Now it's coming.
Okay.
Okay. In the next 10 minutes, I will present to you some technical details of how we develop a HATSA model and vulnerability models that John's just presented to you the overview of the project. In the in HATSA modeling, we use the Monte Carlo simulations to develop typhoon tracks and to build the wind map for Vietnam Basin typhoon with the different probability of HATSA occurrence. So this figure is the typhoon known that hit Vietnam last month, causing 6 deaths and huge damages to structures. In typhoon simulations, we use historical data from 1951 to 2009. 2019 to generate artificial tracks through the development of 3 models. The GENESIS models is to simulate the starting of the typhoons, which is the square mark here. In the bottom, the red dots in the bottom figures are the historical genesis location of typhoons, and the blues are the generated genesis locations of artificial tracks. The propagations models is developed to simulate how typhoon translate, which is marked by the circle points, as you can see in the figures. And finally, the lysis is developed to simulate the end of a track, which is star marking here. In this figure, the left figures with red lines are the historical tracks from again 1951 to 2019, and the blue tracks are the simulated tracks. From these simulations, we develop a typhoon wind map for Vietnam. The contour lines are the gradient velocity, the gradient extreme velocity for 50 years of return period. So in vulnerability model, we're trying to answer the questions: what is the probability of failure of a structure in typhoon? So we use, to this end, we use CFD and wind tunnel tests to model the structural response to wind. This video shows you one type of response of lighting poles to strong winds. The phenomenon is called galloping, and the loud vibrations of the structures can cause damages to structure. So galloping can occur under certain conditions where the aerodynamic coefficients, which you see here, is negative and the wind velocity is higher than a critical value. We develop an analytical model to generalize existing model to assess the critical velocity for galloping occurrence. We also use the CFD simulations to simulate wind flow around a particular cylinder and estimate the wind force and pressure on it. We also use the wind tunnel test to measure the amplitude of vibrations against wind speed. And finally, we estimate the probability of failure of structure in typhoons. These terms can be obtained from Hudson model that I presented before, and this term can be obtained from a galloping model. The blue and green terms here in the formulations correspond to the green and blue lines in the figures. The green line is called a fragility curve of poles, or particular poles, and the blue line is the probability of wind speed. From this line allow us to calculate the probability of failure of poles corresponding to specific wind directions. And this figure shows you the probability of failure of poles for different wind directions. And this is how we develop models to assess the probability of failure in typhoons at the moment. Thank you very much. These are the details of our research in this project. Thank you.
Thank you very much, Sir Nguyen. So, the next presentation will be done by Dr. FRANKE, Senior Lecturer, Faculty of Engineering, Vietnamese-German University, Yong City, Vietnam. Dr. FRANKE is a Senior Lecturer in Fluid Dynamics at the Vietnamese-German University in Yong. Before joining Vietnamese-German University in 2012, he worked for 14 years at the University of Nottingham, Germany, where he also was interim chair of fluid mechanics for 3 years. His expertise is in computational fluid dynamics, CFD, and computational wind engineering, in particular in the simulation of urban wind environment at micro scale. So I will let Dr. Jörg FRANKE to start his presentation.
Yeah, thank you, Dr. Boy. Hello, everybody. Also from my side, first of all, thanks to EURAXESS for allowing us to present our research here. I hope everybody can see my slide now. I will first introduce a little bit about the university, because we are now changing from Nottingham, a very old established university, to the Vietnamese-German University, which is a new university that has been just founded 12 years ago in 2008 as a public Vietnamese university, and founded it was by the Ministry of Education and Training in Vietnam and the state of Hessen. It is the first new model university in Vietnam of a totally planned 4, and it follows German study, and the university governance model tries to implement that in Vietnam. The other 2 new model universities are now the Vietnamese-French University and the Vietnamese-Japanese University, both located in Hanoi, in the capital, and we are located not even in Ho Chi Minh City. We have a small campus over there, but our main campus is in Binh Duong province, which is around 40 kilometers north of Ho Chi Minh City center. We currently have 1,600 students, and up to now we have 900 graduates that are continuing successfully in their career. The students are currently studying in 7 bachelor programs and 7 master programs that we are offering in collaboration with German universities, providing either a double degree for these programs or a single degree from Germany, so a purely German degree. You see from the color coding, we have a majority of our study programs in the field of engineering. That's why the Vietnamese try to bring the Germans in to have this as their strong point, the engineering expertise. And we also have study programs from economics. At the university in Vietnam, we have local staff, 40 lecturers and 35 research assistants at the moment, but 40% of the modules of these study programs are taught by German professors or international professors that are normally coming to Vietnam. So we have a lot of traveling for people coming for 2 to 4 weeks to Vietnam and providing lectures here. But you know, currently in the COVID situation, this has been stopped and everything is handled online. The university is generously supported by the Vietnamese government and also by the German government that covers all the costs on the German side and partially the costs on the Vietnamese side. And in addition, we have a loan from the World Bank. Vietnam has this loan of the World Bank of $180 million that should be spent, part of it for laboratory equipment, but the majority of this funding loan is for a new university campus, which is currently built, and it should be finished this year. Here you see in the background a sketch of this university campus, which has been designed by Mercado and Silvetti, architects based in Boston, USA. And I hope you can see my, my mouse pointer. So this is here the main building for the administration. Then we have here the faculty buildings with the laboratories and where the staff is residing. These are buildings for lecture halls and seminar rooms. And we have here our nice library, big library, ceremony hall. And on the right-hand side, you see the 2 dormitories that will be built. You see, we are proceeding well with the construction. So this is from some weeks ago, a picture of the library, how it looks currently. And this allows me to transition to presenting my own work at the university, because some years ago already in a student work in a master thesis, we started to investigate the wind fields at this planned campus. At this time, of course, only based on artificial models that we used in the computer, which is called computational wind engineering. So that's my main background, my research. So my lab is on computational wind engineering, and the general definition of this research field is you're using another computational approach called computational fluid dynamics, CFD in short, for applications that are typical for wind engineering. John already introduced the loading, and Cung also introduced the loading. That's one aspect. Other problems are simply wind distributions in urban areas for comfort assessment, or you have it for pollutant dispersion. These are the main approaches that you can have. And here's an example, Oklahoma city center, where you see, first of all, close to the ground, the pedestrian winds at 2-meter height. And you see here, this red isosurfaces. This is how a pollutant that has been locally released goes out. Now, in this very broad field, my main interest is on quality assurance of using computational techniques in fields of high economic impact, which is definitely the construction and the safety area. And therefore, we are looking always at the comparison of our data with experiments. This is known as validation, nowadays known as validation. And the last bigger project that we were still working on, is validation of urban wind field simulations. And the new approach was that we have been doing it in Vietnam with a time-dependent and therefore also much more time-consuming approach, which is known as large eddy simulation, or short LES. The model is shown here below. This is a model for a typical European city center, not definitely an Asian city center. You see these block-like structures, and we have high quality measurements from the friends and colleagues from the Environmental Wind Tunnel Laboratory at the University of Hamburg in Germany in this field. And we here in Vietnam performed the simulations, and having now at hand the time series of the simulations and the time series of the measurement data, we could compare the statistical outcomes like the probability density functions, which you see here at a small location in this building block here, left corner. And that is one of the possibilities to compare it. If it comes to validation, you want to have a quantitative comparison in addition to the qualitative one. And this is based on the cumulative distribution function, which you see over there. So like in the resilience risk modeling, now also in the, let's call it, simple approach of simulation, it's a lot based on the distribution functions when you're starting to deal with it time dependent, like in reality. We are normally using open source software for that. So the simulations have been done with OpenFOAM, and for the data analysis, we used also open source Octave, which is a free MATLAB implementation. We also use the commercial software ANSYS, where mostly ISIM is used for grid generation still due to tradition, and Fluid when we are running simulations more for the steady simulations. Our high performance computing hardware at VGU is not so well developed. We started off with some simple, relatively small workstations. Recently we got to Surface, where the boldly highlighted one at the end is now a machine where we can really work, but I'm always looking for the possibility to get real high performance computing resources so that we can run our very large models that also need a long time to compute the time dependent solution. Now, this is done ideally in networking, and this brings me now to the IRIS project, which I put towards the end. So we have been done within the project a lot of networking and outreach, and the main thing was delivered dissemination of results during workshops and symposia. We started already 2018 at the beginning to get an overview. That was done in Da Nang. We're working on Storm, so the city of Storm was the right location to have this first workshop. We had 7 speakers and 27 attendants. And for me, the very positive thing is we managed to bring together for the first time, obviously, the meteorologists, Vietnamese meteorologists, and a Vietnamese wind engineer, and they had really nice discussions at this workshop. Briefly afterwards, at the Industrial University in Ho Chi Minh City, we organized the first symposium on wind and structures. And the year later, at the same location, the second symposium, which was on aeroelasticity simulation. We were happy to have 2 more international lecturers from abroad who contributed in there, and we were very happy to have 60 participants at that time. And now we're planning our next workshop, which is then on risk modeling, putting everything together like Cung just presented. That should be in December in Hanoi. Due to the travel restriction, that should be an online workshop or a mixture of a present and online workshop, and we hope that we will reach 60 participants, maybe not only in Hanoi, but all over Vietnam. In addition to these workshops, we did training and an outreach activity. Training was last year on computational fluid dynamics performed by more colleagues than one, from Nottingham in Ho Chi Minh City. And we had a very nice event at a high school where we introduced our project and civil engineering and these topics in general to students in a STEM project called Standing Strong in Strong Winds. Now, for the IRIS research project, we have been deeply involved in all the other stuff, and we are now taking over the results that Cung and the Nottingham group has produced for the typhoon wind fields, and we want to apply it for a typical Vietnamese coastal urban area. So what you have seen in the wind speed map that Cung has shown, that is now design wind speeds, 50-year return period, 10 minutes averages, but they are at the gradient height. So this is relatively far away from the ground, and design is normally, of course, done by wind speeds that are close to the ground. You see here this nice model from the publication that shows a typical typhoon wind field at gradient height. Now, if we want to go to the surface, where normally 10 meters is the height that we want to see the wind fields that we need for design, we have to take into account the local roughness of the ground and also the topography, whether there are hills or any other elevations or valleys around there. To do that, typical approach that we are also going to follow is we are using a model to use the gradient wind speed that we get from a simple model and our track position from the track modeling, and then we fit it with a wind profile over a flat terrain with a given roughness representative of the area where we are. Then we have the wind profile over the flat terrain, and then we are going to generate by CFD simulations, by steady, so not time-dependent CFD simulations. We are producing topographic multipliers, including wind directionality. 16 wind directions shall be included, and then we can modify the local profiles in accordance to the local topography, and thus the surface wind speed that can then be used as a design wind speed. Now, a problem, small problem that we are currently investigating is there is not only one simple model for the wind profile over flat terrain. There is more models, and when we do CFD, we also need turbulence information, not only the mean wind speed, and there we are currently investigating what kind of model is the most suitable. A small collection is shown in this figure in the center below that you see. When we have this model selected, then we want to apply it to a generic coastal urban quarter. The people from Vietnam at least know there's a lot of development going on the coastal side, and this is of course the region where most of the typhoons make landfall and are still very strong coming from the sea. And we want to investigate how this urban area modifies the wind speed and what we can predict with, again, a steady simulation. So here is a model of what we are going to do. So you see here, just as a block currently, a mock urban area, so just a generic urban area. We will put it on a numerical turntable so that we can turn the area towards the wind, allows us to investigate these different wind directions, and the wind will always be coming then from the seaside, so that we only have to take into account a maritime boundary layer flow for this one. And the topics to be investigated is, we want to know then within the urban area the local wind fields. So we want to see how the urban area changes the wind fields when they come in with a typical profile over the sea for a typhoon. We want to compare it also with a standard neutral atmospheric boundary layer flow and see whether there are substantial differences, and want to investigate also the influence of these different profiles that I showed you. So that's all from my side. Thank you very much for your attention. And whenever you have any recommendations or questions in the following Q&A session, we are very happy if we can answer that and at least can hear it from your side. Thank you very much.
Thank you very much, Dr. Jörg, FRANKE. So now we will have some time. So we are on time. It's okay. Your presentation is perfect. I have also some question, but maybe we will let some people from the public. Maybe they have some question. For example, Mr. Tung Huang. For the public members, if you have a question, you can turn on your microphone and ask directly in voice, or you can also type your question in the message panel. Mr. Tung Huang.
Okay, thank you, Mr. Bao. Do you hear me?
Yeah. Very well, very well.
Thank you very much. I just do a quick introduction. I'm a research fellow in NTU Singapore. Yeah, my research also relate to the civil engineering, but focus on the construction material and geotechnical engineering. I'm going to come back to Vietnam next year for working on the university in Da Nang University in the middle of Vietnam. And I'm looking for the join to the cooperation research project with UK or Europe, and so I'm wondering how can we join in the research project like this project, or maybe do any cooperation. So I want to learn how the Vietnamese university and another university in UK can cooperate in the research project. Yeah, this is my question.
Okay, thank you, Mr. Tung Huang. Maybe I let first Dr. Owen to have some response, and after if FRANKE want to add some supplementary material.
Yeah, thank you very much for the question. If you bear with me just for a few moments.
Sure. Yeah.
I'm just going to try and find a slide from another presentation that I did. And if I can get that up and share it, it might. Oh, let me just go. I thought I had. Oh. So let me bear with me just for about another 5 seconds, and
Sure, no problem, Professor John.
So I'm now going to share my screen. Okay, can you see this?
Yeah.
Okay, so there's just a few places where if you want to find funding in order to collaborate with UK partners, there are various international collaboration funds from the UK. I'm sure EURAXESS also have various sources of funding on their website, but you know, Royal Society have international collaboration opportunities. The Royal Academy of Engineering do the same. The Newton Fund, also the Leverhulme Trust. The RC UK probably a little bit more difficult at the moment. So those are some sources of funding from the UK that you might explore. What you do need to do is to find someone in the UK who's working in your area. So geotech, we have a strong geotech group who may be people to talk to. Let me just see if I can move on to the next slide. So there are other sources of funding also for collaborations in Vietnam and EU. So I think NAFOS offers some funding for collaborations, including a UK Academies collaboration program. There is short-term collaborative research, again through NAFOS, and then the Marie Curie actions, both in terms of individual fellowship, staff exchanges, and innovative training networks are all opportunities for getting, that's not just in the UK, that's across Europe. So I'm sure EURAXESS have more available or more links, but those are just ones off the top of my head.
Okay, thank you very much, John, for a very complete answer.
Yeah,
So I don't know if Jörg, FRANKE, you have all the additional information from Germany for
It is similar for Germany, but most of our programs that are with Vietnam are cooperative programs. So you also have to find a German partner, and then you have to apply in Vietnam. So the Vietnamese researchers apply in Vietnam for Vietnamese funding from either NAFOS or the ministries, and the Germans on the German side, and then you get a co-funding. For our IRIS project, it was very nice. I was approached by the colleagues from Nottingham and from Industrial University in Ho Chi Minh City, whether I would like to join. And so that was a very nice way to join into the project.
Yeah, thank you. Maybe I will take some time for discussion because I think this is an interesting question. Maybe all the people in the room are interested also for the opportunity. I know that, for example, actually between Vietnam and Germany, different collaboration project, corner project. So maybe it's interesting to look also. And for Dr. Cung, for example, can you share some experience because you was a young PhD already doctor? How, for example, how you have contacted John or FRANKE? Can you share some experience?
Thank you, Dr. Bui. Well, from my experience, I tried to use the links that John already presented to you. That John just showed you the complete list of different links, different resources for fundings to find collaborations, and I was looking into that. So at the moment, from my experience, we can, you or others, young researcher can see from Newton Fund panels and GCIF, they usually update the lively resource for funding and for collaboration between Vietnam and the UK. And from Vietnamese side, NAFOSTET is an active funding body that provide often fundings for spend short time to do research in the UK, or a short time collaboration between the two countries or the two institutions. Yeah, so I think just you need to just follow the links that John had just presented, and I think that for I think it's cover almost all opportunities that we can explore.
Okay. Okay, thank you, Dr. Cung. Now we have a question from Maya, but she doesn't have a stable connection, so I will read her question. Thank you, very interesting project presentation. Do you see any practical applications of your model, in particular for early warning systems? Who would be the end users? Thank you. So, who want to answer this question? Or someone who wants to start?
I'm happy to start. Shall I start?
Yeah, thanks, John.
I guess early warning for typhoons is more the domain of the meteorologist. And so there are already very well developed meteorological models for specific typhoons, and using satellite images and elsewhere, we can see storms developing out at sea, and the meteorologists are very good at predicting the track of a given typhoon and predicting where its landfall is going to be, and giving early warning of places that might need evacuating or defenses being put up, urgent defenses. So that's not really what we're covering. What we're trying to do is to develop a model of the hazard that can be used in planning and in mitigating future disasters. So in terms of our end users, we would be looking for local authorities who may be reviewing planning arrangements or building regulations and saying, well, over the next 20 years, we're expecting this much damage to occur. But if we were to change the building regulations in this way, we might reduce those losses by 50% or 60%. So that's one example of an end user. The other end users might be companies that operate power distribution networks, telecommunication networks. So if they are able to predict likely losses of their infrastructure, and then they can look at interventions that they can make in order to reduce those future predicted losses. So maybe changing the design of their poles, changing the design of transmission towers, maybe doing remedial work, maybe defensive situations. So those are two examples of potential end users.
Someone want to add something? No. Okay.
Oh no, not really. John was all really very comprehensive in doing that. Well, I mean, if we provide an update on the wind map in relation to the expected typhoon wind speeds, that is something from which any designer that puts up some infrastructure on the earth in Vietnam can profit. That is something which is important, I guess. And currently there's a big discussion on offshore wind energy, and I guess they would also be interested in the probability of having wind velocities exceeding a certain speed.
Okay, for this question, maybe I will ask Cung to reshow his presentation, because I have maybe a similar question. Cung, can you share your presentation?
Okay, just bear with me a second. just share my screen. Can you see it?
Yeah.
Yeah.
Good. You have maybe the fourth or fifth slide where you have a map with some chart, some curve, maybe 4 or 6. Yeah. Yeah. For example, the 9. Yeah. This.
Okay.
Can you explain more detail about this figure?
So, sorry, could you give us some more detail on your questions? I mean, which detail
Yeah.
would you like?
For example, what is the red color and the blue color, or what is that? The vector or the speed or acceleration, or what are they?
Okay. So the red lines here, well, I'm sorry, this is not clear to see lines, but if you can see the lines here, all of them, all of the reds here are the historical tracks, the tracks in the historical typhoon, and the blues here, some lines here, are the tracks that we simulated. And how to simulate that, I presented here before. For example,
sorry, Cung. Yeah, I see. But what you mean is the speed or the acceleration, or what are the parameter?
you need the input, right? The input.
No, sorry. In the nine slide. Yeah, the historical track, for example. Is the speed, the wind speed, or is the wind acceleration? What is it?
Okay, so to answer your question, I to show you, let me show you this slide. So the track for this is a simulated track or similar to real tracks. It contains informations of the locations, which is defined by latitude and longitude, and from the location of different points here, we have the time in between two consecutive points, which is 6 hours, and we have the speed and translational speed between the 2 points. For example, in 6 hours, it moved from here to here. And we also have information of central pressure and also other parameters like of wind fields, such as sustained wind speed and the radius to maximum wind speeds. And from these informations, we can develop the simulation for each locations of the tracks when it's the central or storm when it moves in over the oceans. And so from that we can estimate wind speed and other parameters. I hope that can answer your questions.
Okay,
so
okay, thank you.
Figure 9, just purely the track, the path that typhoon moves in reality and in simulations. And of course, when we extract all information in our simulation, we can obtain wind field data, wind field informations.
Okay, thank you. So now we have other questions from Mr. Minh. For example, do we have any data for Vietnam's construction? So, and he has also the second question. The data could use for predict the weak structure of Vietnam house, for example. Thank you. So, do you have some data?
So me, should I answer the question or?
Cung, I think that's one you can probably answer.
Yeah, best.
Yeah, for example, the information of building dimensions and other constructor, this is not we're looking at, and this is not what we investigated in this project. And but in the future, we are interested in investigating more and more the wind effects and typhoon effects on different kind of structure. For example, residential buildings, tall buildings, or infrastructure networks, power lines, and so on. So focus on particular types of structure. We're trying to collect real data to establish to use for input in our model. So at the moment, the answer is no. Yeah.
Yeah. So can I just add a little bit to that? So I'm sure there is data available in Vietnam, but also there are many building structures, many of which are quite old, many of which won't have been fully maintained in the way that maybe we should do. I mean, it's the case all around the world. I'm not picking on Vietnam. And to understand the state of that building infrastructure is really important if you are to make a more resilient infrastructure in the future. And there are many ways we can try and derive that data. We could go and try and do surveys, but that would be very expensive and take a lot of manpower. The other thing we can do is look at how historical structures have stood up to historical typhoons. So when an event happens, when a typhoon strikes a given area, we can go and look at the damage that's done and try and learn from the damage and see if there are any repeated types of damage that we could then implement within our model. And then we can look at things like insurance losses, which are often a good source of aggregate data. So those are just a few examples. So the data is really important to inform the risk model and the model of losses, but it's data that isn't, because there's often so much of it, it's very expensive to collect.
Yeah. Mr. Van Dinh, do you want to ask directly by the voice? Do you have any microphone? So I see you raise the hand. Mr. Sam, yeah.
Hello.
Hello.
Yeah.
Everyone can hear me?
Yeah.
Very well.
All right. You know, my question is, because of the data, I know it's important of the data, but you know, in Vietnam, we don't have. I think we may not have the data, the historical data yet, and whether we use any type of data like you know, videos, and we analyze the videos, how the storms that hit into some places, and do we use that to be like a data for the model, or we have to experiment on some devices or equipment who could fit or build the data from now, because you know, in the middle of Vietnam, the middle area in Vietnam, there's a lot of storm that hit into that area, and it's not the building, it's very weak structure, and I think that may help to predict you know, some damage, or can help the people to avoid the disaster in the future. Thank you.
Thank you.
Okay.
Cung, would you like to answer? Because you were even involved in looking for data, or John?
So I think there are lots of different sources of data, and just looking around the world at what other people have done in trying to gather data. So one thing you can do is, when a major storm strikes, is get teams of researchers to go and literally walk around the impacted area and take photographs and take measurements and so on. But that again could be expensive and difficult to realize in a short time frame. I know people who are using satellite images. So you can use a satellite image immediately after an event to look at damage to structures. You can look at damage to forests and crops and things from satellite images. I know in some parts of the world they're using what they call citizen science, which is where you get a mobile phone app and you allow citizens to report what they're seeing and to log damage. I know that was done a lot after the earthquake in Haiti a few years ago, and that was used to gather data on the performance of buildings in that earthquake. So there are lots of different techniques that are used in different disaster situations for gathering data.
Yeah, I think
and we would like to try some of those.
Yeah. In Vietnam, we have also the map of wind. So maybe here we have Mr. Nguyen from Imtech. Maybe he wants to add some information. Mr. Nguyen, do you want to talk directly?
Yes, can you hear me right? Okay.
Yeah, very well.
Yeah, thank you. Sorry for disconnected because I got another meeting. But anyway, I'm interested in the topic of your meeting actually, and I'm a meteorologist from Meteorological Hydrological Administration Vietnam, and from our office, we got say 30-40 years of historical data for typhoon, cyclone in general, and so that is something you can think about the historical data for typhoon in Vietnam.
Yeah, I guess we know that. Cung, did you take that into account?
Yes, so thank you. This is very interesting news and helpful data. If we could have that for example, validation and carried out some further analysis comparing with our simulations, which is very helpful. I just have a question that have you separated different events, for example, typhoon winds and non-typhoon winds in your data, or you collect everything?
Hymetic analyze. How can I explain? Okay, in our database we have the typhoon wind type every 6 hours data, okay, for 30-40 years, in the last 30-40 years. Wind, pressure, and what else? And rainfall. Yep. So that is the three main elements that we have so far. So that is for the cyclone database, okay. And for the other severe weather events, we have flood as well. We have yeah, I think I can name some. I can name some of the severe weather events type that we have in our database.
Yeah. So could we have some could you have permissions to assess the data or well, or could we have some your contact so that we could?
Sure, I'm very pleased to be, you know, to be a contact in this project. I would say, from the laws say that we have any project has to pay for that data. Okay.
We know.
Otherwise, there's some if the project is controlled by the government, and then we will provide freely. Yeah.
Okay.
Okay. Thank you. So we might need your contacts for maybe further collaborations or exchange informations.
Yes. Mm-hmm. One example that I want to share you guys now today is just recently we analyze the frequency of wind and rainfall 40 years in 40 years long typhoon in a city in the central part of Vietnam, and that data will be used for the solar plant construction.
Mm-hmm.
Okay.
Yeah.
Yep. And the owner, the solar plant owner want to have some analysis like what is the frequency in the next 40 years, 50 years of the that extreme gale or torrential rainfall. Mm-hmm. Yeah, so that we have to, and we got answer that kind of question in that report, and we just done it, and that is a project how can I say, loaned by the ADB, Asian Development Bank. Mm-hmm. Yeah.
Yeah, thank you very much. That's really helpful information. When we have a specific track that you recorded with the specific data, that will be very interesting for us when we are going to test our wind field models in the surrounding. Yep. So as Cung said, I do not know how we can best manage to get into contact. But I guess EURAXESS will help us because you registered. And so we will definitely come back and contact you. Oh, Jenny is here.
Yes, I just had to show my face because this is becoming really a very interesting discussion, because there is, especially because there is a new collaboration that is blooming. So don't worry, we are going to make sure that you are getting in touch with each other. We will be in touch and put you two together. Thank you.
Yep.
Thank you very much.
Yeah, so I just provide his email. I've got it here. Thank you.
Good.
So if are there any other people who want to ask or discuss?
May I share with you some information?
Mm-hmm.
Yeah.
Sure.
What we have the longest database from Indochina. The typhoon data, I mean, from the years 1907 to 1930 something. That time was colonized by French, and we still get that database. That is a very good one, I would say, to compare in the last 20 years, recent 20 years, etc. To, you know, we may think about an issue like how the track has a change in the last 100 years over Indochina. Things like that. We can compare. Yep. And very lucky that my my PhD study. I was EURAXESS data, and yeah, we got that one.
Okay.
Yeah.
Are the old data already digitized, or do you still have them only on paper? The ones
For the
from
French
1900.
one, okay. For the French time, that it was published in books and figure and charts only.
Okay. And you digitize it? You put it onto computer?
Yes.
Okay.
Yeah.
Okay.
And,
This is now then a very valuable source of the historical data.
Yeah.
Thank you for this additional information.
Thank you. Maybe the last question is for John. In your faculty, you have a wind tunnel. You have a wind tunnel for the wind tunnel test.
Okay, yeah, we have. So within the faculty, we've got quite a lot of wind tunnels of different types for different types of tests. So we have one which I use, or my researchers use, which is principally an atmospheric boundary layer wind tunnel. So it has a working section which is 2.4 meters across and 1.8 meters high, and has a fetch of about 14 meters. And we do use that for some aerodynamic tests as well. And then within the faculty, the other one which is most relevant for wind engineering is we have a new higher speed wind tunnel, which is used in aerospace engineering, where we haven't yet put aerodynamic models in for bridge decks, but very much that's what I want to do at some point in the future. But then we've got lots of other very specific wind tunnels for studies on boundary layers and riblets and things like that, but that's not stuff that I work with.
And for the research, we must pay to use that. For example, for research collaboration, can we use the wind tunnel?
So I think if there is funding to do a collaboration, then we can get the funding to cover part of the use of the wind tunnel. So it's a matter of, when we put the proposal together for the collaboration, of making sure we include a request for funding to use the wind tunnel.
Okay, thank you. So it's also time. Thank you, Mr. Nguyen, to provide his information. You have also this link on the message. So I think we can stop our webinar here. Thank you very much for your presentation. Thank you, EURAXESS, for the organization of this event.
Yeah, in behalf of EURAXESS, I'd like to thank Dr. Jörg FRANKE, of course, our moderator, Dr. Quoc-Bao, Dr. John Owen, and Dr. Cung. Thank you so much for spending your time with us, and everyone, the attendees. It was an amazing discussion. I hope that you continue to be in touch, and we will also definitely be in touch in the next days. Have a nice weekend to everybody.
Thank you very much.
Thank you.
Goodbye, everybody.
Bye, thank you.
Bye-bye, everybody. Thank you. Bye-bye.
Bye.